Hello, my name is Sticky, and today we're going to be talking about... Yes, the history of chemistry. Now where should I begin? At the beginning, that's where I'll start in 1000 BC, where the humans made fire. That was closely followed by pottery. Then they fermented an early type of beer, and then they extracted metals and chemicals from ore and plants. It was the beginning of the branches of chemistry.
Oops!
Anyway, enough of that fooling around. Let's get on with the next major event. In 440 BC, after pottery and fire was discovered, the theory of atomism started. Aristotle began this theory when he denied the existence of atoms. He said there was no scientific proof. There is no such thing as atoms. Our third event is something completely different from atomism. After the discovery of fire, humans quickly discovered how to make glass and other things, and the method of chemistry known as metallurgy spread around the world and soon became popular. The Egyptians made it popular because they started mixing different liquid metals. Let's get right on to the fourth event in the history of chemistry. After the spread of metallurgy, the people of the Bronze Age began to mix and study different metals. And because of the strengthening of metal weapons, this meant that early metallurgy decided the outcome of battles.
No!
From the Bronze Age to the 1300s, there is a big gap in our knowledge because there are no writing about the history of chemistry, although it next turns up in the 1300s, and I will now talk about it. So we will now continue our journey through time to the next major event. Our next event is about alchemy and how it spread through the Arab world from the 1300s to the late 1700s. The Arabs translated Isaac Newton's works on alchemy, and they soon began trying to find the elixir of life. And although it was never found, some alchemists today still believe that there is an elixir that gives life to inert bodies.
Oops!
We are now going to move on to the sixth event. During the late 1700s and early 1800s, there were many advances in chemistry. In 1754, Joseph Black isolated carbon dioxide and named it the fixed air. And in 1800, Alessandro Volta created the first chemical battery. And then Joseph Proust proposed the law of definite proportions, which states that elements combine in small whole number ratios. And so it was. This was the beginning of modern chemistry.
There's antimony, arsenic, aluminum, selenium, and hydrogen and oxygen and nitrogen and rhenium, and nickel, neodymium, neptunium, germanium, and iron, americium, ruthenium, uranium, europium, zirconium, lutetium, vanadium, and lanthanum, and osmium, and astatine, and radium, and gold, protactinium, and indium, and gallium, and iodine, and thorium, and thulium, and thallium. There's yttrium, ytterbium, actinium, rubidium, and boron, gadolinium, niobium, iridium, and strontium, and silicon, and silver, and samarium, and bismuth, bromine, lithium, beryllium, and barium. There's holmium and helium and hafnium and erbium and phosphorus and francium and fluorine and terbium and manganese and mercurium, molybdenum, magnesium, dysprosium and scandium and cerium and cesium and lead, praseodymium and platinum, plutonium, palladium, promethium, potassium, polonium and tantalum, technetium, titanium, tellurium and cadmium and calcium and chromium and curium. There's sulfur, californium, and fermium, berkelium, and also mendelevium, einsteinium, nobelium, and argon, krypton, neon, radon, xenon, zinc, and rhodium, and chlorine, carbon, cobalt, copper, tungsten, tin, and sodium. These are the only ones of which the news has come to Harvard, and there may be many others, but they haven't been discovered.
You know that guy back there? The one resting on his elbow with the beard and the long hair? Well, that guy's Dmitri Mendeleev, and that's what our next event is about. So anyway, our next event is about Dmitri Mendeleev and how he developed the periodic table. However, he didn't do it alone. He was helped by Lothar Meyer, another famous chemist. They worked together until they created the periodic table. And they managed to work out what germanium would be like before it was discovered. Luther, I've got it! Let me see! Wow, you've got it! Jolly good! This is going to change chemistry forever!
ABC, it's easy as 1, 2, 3. All simple as do, re, mi. ABC, 1, 2, 3, baby, you are the girl. It's easy as counting.
After the success of the periodic table, many chemists started developing quantum chemistry. Those chemists include Edward Teller, Robert S. Mulliken, Max Born, Robert Oppenheimer, Linus Pauling, Erich Huckel, Douglas Hartree, Walter Heitler, and Frank London, to name a few. Whew, that was a lot of chemists. Of course, I'm the best chemist. No, you're not. You don't even know what an atom is. Yeah, right. And I think you think you hold the periodic table upside down. No, I'm the best chemist. You've got to know that. Excuse me, don't forget me. I'm the best chemist. No, you're not. I'm the best chemist. I am. In the mid-20th century, the atom bomb was developed. And since then, chemistry has been changing every day. Now watch that flask. Oh, no. We now have the credits. This tells you all the people that helped me make this video.
There's antimony, arsenic, aluminum, selenium, and hydrogen and oxygen and nitrogen and rhenium, and nickel, neodymium, neptunium, germanium, and iron, americium, ruthenium, uranium, europium, zirconium, lutetium, vanadium, and lanthanum, and osmium, and astatine, and radium, and gold, protactinium, and indium, and gallium, and iodine, and thorium, and thulium, and thallium. There's yttrium, ytterbium, actinium, rubidium, and boron, gadolinium, niobium, iridium, and strontium, and silicon, and silver, and samarium, and bismuth, bromine, lithium, beryllium, and barium. There's holmium and helium and hafnium and erbium and phosphorus and francium and fluorine and terbium and manganese and mercurium, molybdenum, magnesium, dysprosium and scandium and cerium and cesium and lead, praseodymium and platinum, plutonium, palladium, promethium, potassium, polonium and tantalum, technetium, titanium, tellurium and cadmium and calcium and chromium and curium. There's sulfur, californium, and fermium, berkelium, and also mendelevium, einsteinium, nobelium, and argon, krypton, neon, radon, xenon, zinc, and rhodium, and chlorine, carbon, cobalt, copper, tungsten, tin, and sodium. These are the only ones of which the news has come to Harvard, and there may be many others, but they haven't been discovered.